All right. Cool. So I'm in the code day 18. Gotta limber up. Cool. So where did we leave off yesterday? Yesterday we were. I better turn these notifications off. That's battery. Still getting no. Just go away. Okay. Still getting used to Big Sur. All right, there you go. Where did I leave off yesterday? Yesterday, right, we were going to maybe investigate making some changes to how we, right, we're going to do this. Instead of pre-expanding the board, let's just assume a mirror above the second dimension. So we were going to do this, and we didn't because, frankly, I was busy and I didn't get to it. But we're just going to ignore that for now and move on to day 18 because I am impatient. Okay, so it's going to be day 18. And let's see what day 18 has in store for us. Cool. Day 18. Return to your advent calendar. Okay, as you look at the window and notice a heavily forested, this is operation order. Okay, notice a heavily forested continent slowly appear over the horizon. That sounds nice. You are interrupted by the child sitting next to you. They're curious if you could help them with their math homework. The answer to that is always no. I don't remember anything about math, even basic stuff. Unfortunately, it seems like this math follows different rules than you remember. I think our parents had this, like the boomer generation, where they learned math one way and then we learned math in a way called the new math. Yeah, anyway, okay. The homework, your puzzle input, consists of a series of expressions that consist of addition, multiplication, and parentheses. Just like normal math, parentheses indicate that the expression inside must be evaluated before it can be used by the surrounding expression. Okay. Addition still finds the sum of the numbers on both sides of the operator, and multiplication still finds the product. However, the rules of operator precedence have changed. Rather than evaluating multiplication before addition, the operators have the same precedence and are evaluated left to right regardless of the order in which they appear. So, for example, the steps to evaluate the expression blah are 1 plus 2. I wonder if that makes our lives easier. Parentheses can override this order. For example, here's what happens if parentheses are added to the form 1. Okay, so parentheses get evaluated first. Here's a few more examples. And of course we can nest parentheses. Before you can help with the homework, you need to understand it yourself. Evaluate the expressions on each line of the homework. What is the sum of the resulting values? Okay, as you can see, I'm well rested and ready to attack today's complex problem. That was a lie. I'm not well rested. I don't know why. I think it's just the weather changes, not sleeping great, but that's okay. We're gonna do it anyway. So let's man, I'm already thinking about ways in which this is going to be difficult. The biggest thing that jumps out to me is the fact that we're going to be looking for nested parentheses, and that's going to be tough. Yeah. Okay. New folder. Day 18. Sometimes I get lost in thought thinking about, like, what if we do it this way? What if we do it that way? And of course the answer to most of those little like, I don't know, mental side journeys is, oh no, that wouldn't work. And of course I should be talking about it because that's kind of the point, right? Is I should be explaining my thoughts, and I will. But first I'm going to clean up the markdown so we have some nice pretty markdown. Cool. So this right, parentheses, plain and here are a few other examples. Before you need to understand it yourself. Evaluate the expression in each line of the homework. So which one is the homework? That's example, example, more examples. I think this is the homework. So let's indent that. Input equals input. Let's make sure that that's actually the homework. Parentheses can override. Here's what happens if they're added. And here are a few more examples. Okay, so this is the example, and then this is the answer that they give. Oh no, this is how you would. This is the breakdown of part one. So this is not the input at all. So let's leave that. Let's leave that as a plain text block. So this is, I guess this is the input to evaluate the expression, and then you add parentheses, and then that's the number that you get back. So really, this is the input. So let's just cool. Let's make our usual sections. So we're gonna have definitions. What are these? These are heading 2s. We're gonna have tests, and then we're gonna run it. So I guess our input is gonna be that, and what we're gonna want to do is we're gonna want to assert that 51 is evaluate. I was gonna just call it eval, and then I'm like, nope, that's keyword. So evaluate input. Okay. So how are we going to solve this? That's the real question. So what we need to do is we need to evaluate this in order. We need to evaluate 5 plus 6, then 4 times that, then 2.3. So basically we need to evaluate the innermost parentheses. Each one of these parentheses we need to, or each of these paren groups, we need to evaluate to a value. So what we want to do is we want to do exactly what they're describing up there. We want to see here, this is a paren group, this evaluates to 6. This is a paren group, but it contains another paren group, and then 4 times 11 is 44, and then we want to evaluate this outer one, and they go in order. So we would then evaluate this group first, and then we would evaluate, like, yeah, so we'd go 1 plus 6 is 7, and then we do 7 plus 44 is 51. And so, okay, so how are we going to do this? This is going to be kind of tricky. I guess what we want to do is we'll want to do something. This is going to be similar to a compiler, like how a computer compiler works. And a computer compiler takes, like a programming compiler takes, is there any other kind of compiler? I don't know. We'll just call it a compiler for now. So what a compiler does is it takes in a syntax and it tokenizes the syntax. So like this is an expression, this is an expression, this is an expression, and then like this, the outer thing, is also an expression. So really I think what we want to do is we want to turn this into a series of expressions, and then finally yeah, like at some point, excuse me, we're going to end up with like 1 plus 2 plus 3. Like this is going to be broken into sub-expressions. Like we're always going to have a left side and a right side, and then as soon as we have an operator, and as soon as we have those things, we're going to try and evaluate it, and then we're going to do it again. So we're going to have we're gonna have two steps. We're gonna have we need to tokenize. We need to tokenize the input. And then what that's gonna give us is that's gonna give us basically an array of expressions, is what I think it's gonna do. It's gonna give us basically that, and then that. And each one of these arrays is going to be it's going to be like a value almost. So we're going to have this outer paren, and then we also need to capture the operator. So so we need to break this down. So each, I guess arrays is a really bad way to look at this. What we really want to do is we want to break it into a series of nested expressions. And the nested expressions are either going to be an integer, which means we're done, then an operator, then another expression, which is either going to be an integer or an expression. So yeah, we're gonna have to tokenize the input so we get this tuple, right? So we get expression, operator, expression. And then each one of these can be an expression, which is, operator expression, or it could be an integers, but that's what we want. Okay, so let's tokenize the input. So we're gonna have, let's make a class for an expression. And we're gonna have a constructor which takes in a string, and that constructor, so we're gonna have to evaluate this constructor. So the outermost one we're gonna get is we're gonna get this as an expression. And so we're gonna have a left, we're gonna have an operator, and we're gonna have a right, and left, operator. So that's not necessarily true, unless we consider that, okay, because an expression actually can be many of these. It can be, well, I guess a right, we can always, I guess what we'll want to do is we'll want to evaluate the left as a potential expression, because this works left to right, what we want to do is we want to have the left one, and then we want to have an operator, and then the rest, whatever the rest is. And the rest might be a series of expressions. Oh, actually it's the opposite, isn't it? We're gonna have a rest, and then we're gonna have the right value. So in a case like this, we're gonna have the left. Okay. So yeah, what are we? Let's look at the examples and see what we would do here. Okay, so we're gonna do this. So we're gonna have left, and then we're gonna have an operator and a right, and then maybe a rest, right? But the right will either be an integer, or it'll be an open parentheses followed by a bunch of stuff. Okay, it's something that evaluates to an integer. So we're gonna have a left, a right, and a rest. And the left and or the right are going to be an expression. So we need to have a way of evaluating an expression. And that's what we're doing here. So we're going to have left, operator right. Maybe. So what are we going to do? So maybe tokenize is a bad word for this. Maybe what we just need to do is we need to make a recursive evaluate function. Evaluate. And this takes a string. And we're going to we need to like greedily match on all of this, which is why I was thinking maybe it would be a good idea to go through character by character and make arrays. And that's the point of tokenization. So yeah, let's tokenize the string. All right, and we'll see what we come back with. So we're gonna have a tree of tokens, and that tree is gonna look like this. And what we're gonna do is we're gonna look at, is this always, I wonder what the input looks like. Does the input, is it always single digits? Because that would make life easier. It does look like it's always single digits. Okay, so let's assume single digits for right now. Okay, so we're gonna have this tree, and then what we wanna consume the first character in string. I guess what we should do is we should also how do you strip in JavaScript? Script string strip trim, string trim removes white space. Okay, so just to get rid of any white space. Okay, so we're going to trim the string. So at this point, if we're tokenizing, let's just tokenize something simple like 1.2 or 1 plus 2. So we're going to have we're going to consume the first. It's always going to be one character that we're consuming at a time, and consume is just actually just going to be pop. So it's going to be string or shift rather. So char equals string shift shift. If char, I guess if it's a decimal, dot test char. So if it's a decimal, what we're going to do is we are going to have a literal integer. We should parse float it. Parse float char. Okay, so let's put that tree dot push parse float. Okay. Oops. And then else if it is so we're gonna have to recursively tokenize. Right, so this is gonna take tree. Oops. Okay. So we're gonna take it. We're gonna take a string. We're gonna take the first character off the string. That's taking it off the string. So we'll be removing it from the string. And then, okay, we're gonna push that onto the tree. Actually, I guess what we want to do is we want to have an operation. So it's going to be a tuple. It's going to be a left and right. Okay, so we're gonna end up with a tuple like this. We're gonna have left, op, right. So we're gonna say left equals right, and down here we're gonna tree dot push left, up, right. Okay, so we're gonna take this character. Okay, so if it's a digit, then that's simple. The left becomes this. If it is what are the operators? Plus, minus, times. What else? What do we have in input? Is there anything else but plus and times? No, it's all pluses and times. There's no minuses even. Okay, if it's plus or times, then what we will do is we will say op. I guess, you know what? I want to do this with regular expressions, but like these nested boys are going to be really awful because you have to count the references, the opens and the closes. Okay, so op equals char, and then else if op, or I guess if, rather than doing the string shift, what we should do is we should do this. So if chest string, if the first character is that, and if that, then we want to do this as well. We want to be string shift. Okay, and we'll do this all in a loop. So I mean, we could theoretically just turn this into, yeah, so every meaningful character in here is actually just a single character. We don't have to worry about multiple characters. So what we might be able to do is just turn this whole string into an array. Yeah, let's split it on, yeah, we basically want to make, was it digit, a single digit. I guess we could do 1 to, or 0 to 9, or a plus, or a star, a literal star. Okay, we're in a square print, so I don't think we need to escape that, or one of these or one of those. So dot match. So this is going to be lol, and then the rest. Okay, and this is going to be our input, or our chars. Okay, then we don't need to worry about trimming, and this is going to be global. Okay, so chars, whoops, chars, and chars. Let's just see if this works. Down here, we're gonna do chars match input, and then we're going to log chars. So I guess what we're gonna need log and assert, like we usually do. Log equals console, and assert equals require assert. Okay, we got our input, and we're not going to evaluate anything. We're just going to log the chars. Okay, else if doesn't like this. Let's just put some stuff in here. All right, let's just get rid of that else if. Okay, so what do we got? Match is not a function. Exec is a function. No. Maybe what we want is we want input dot match against the regex. Yeah, okay, so, but yeah, chars. So 1 plus, so is this what we got? What's our input? Here it is, 1 plus open paren 2 times 3 close paren plus open paren 4 times open paren 5 plus 6 close paren close paren. Okay, so this is what we got, and actually I think this is what we got, and actually I think we can avoid that destructuring. Yeah, okay. There we go. Cool. So we've got our characters, and then I guess what we can do is, yeah, what we want to do is we want to break this down into like something nested that we can evaluate. So like we're kind of on the right track here, but what we want the output to be is we want it to be 1 plus, and then we want another array so we can evaluate the inside of this array. So this would be 2 times 3, and then I forget what the next thing is, plus, and then 4 times 5, or 4 times, and then 5 plus 6. So I mean, like this is what we want coming out of this, except these would be strings. So what we could do is we could sort of evaluate this as JSON. Because JSON's already got all this parsey logic built into it. So let's try that. Okay, so we've got chars, and then what we'll do is we'll say chars dot replace. How do you, is it replace all? Or I guess we want to map. That's what we want to do. Map char. We'll just call it C dot replace. So we're going to have an open paren, and we're going to replace that with an open array. Here. And a close paren with a close array. I guess what we could do is we could just say switch on C, and when C or when open paren, then, so I'll show you why in a second. When, whoops, open paren, open square, when close paren. Okay, then when we want to test it, so 0 to 9, then we're going to replace it with parse and C. Actually, we don't even need to do that because JSON thing is gonna do that for us. And the JSON thing should, let's see what JSON gives back for one of these. Let's say JSON.decode or parse, and let's do. That's actually not what we want. What we want is we want input yeah, we want chars equals input match that. Okay, so chars equals input match that, and then let's log chars, see what we got. Okay, and then let's JSON encode chars, JSON.stringify chars. What are we doing here? We're going to, so let's pretend that we've done the substitution on this input. And then we'll go like that, and we'll say, chars equals input match on those, then JSON stringify JSON.parse chars. Or we just, yeah. No. Unexpected token, okay, in JSON. So it doesn't like those. Okay, well, let's just do it the old way. Or the old way? The old way. Okay, so yeah, let's not do that. Okay, those are characters. So this tokenized thing, this is going to produce this tree of left, up, right, and each of these trees what are these trees going to be? So if it's an integer, parse float, integer. If it's a symbol, we're just going to shift the symbol off. And then else if it's an open parentheses. So if it's going to be an open parenthesis, what we want to do is we want to just pass the rest of the string. So we'll try to shift, and then we'll tokenize the rest of chars. Tokenize chars, and that will be right equals. Okay, and then also, I mean, this could be giant switch case switch. When I guess we could switch it on the next char. So when can we do this? I wonder. I guess we're gonna find out. What we could do is we could just we could look at CoffeeScript compiler. Now you can do it in Ruby. I don't know if you can do it in CoffeeScript. So let's switch. So let's do, was it 1, 2, 3? 1 plus, no, plus 3. So let's switch char. So for C in chars. Let's switch on C, and when so I know this works. Alert 1. Else, I guess that's fine. Let's just run this and see if it works. 1, good. When digit. No, this is going to look for the actual thing. Test See, so we got to do it like this. Why is that not working? Test. Let's see. This doesn't work. Okay, so we're gonna have to like that. Huh? I guess C is nothing. Okay, I don't know. Okay, this clearly isn't gonna work. Okay, so let's just stick with our if statement. Okay, so if it's a digit, cool. So if it's an open paren, we tokenize it, and then if it's a closed paren, we want to return tree. So what are we going to do? We're going to do, so if tree dot, we're just gonna push these on, right, to this tree tuple. It doesn't have to be left right. We can just say, yeah, it's just going to be, it's like going to be assumed tree. Okay, so for C in chars. So we're going to go, it's always going to be C, 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 C. And we're going, I guess, C index. And then rather than doing tree dot push C, and then this is, rather than shifting them, what we can just do is tree dot push tokenize chars at index. So this will tokenize up until it hits one of these. And because we're getting an open paren, what we want to do is we want to actually go index +1 and the rest. So we're going to tree tokenize, and if we get a closed paren, so C in, this could just be like plus, or else if C is plus, or C is star. We don't need to use regex for all of these. If C in 0, 2, including 9. Else if C is open paren, and then else if C is closed paren. This reads a lot nicer and it's less regexy. Okay, so then we're going to return the tree, and then, so what we're going to do here is we're going to say, okay, tokenize, we're going to like subtree equals this, and then what we want to do is we want to know how many characters have been, we want to know how many characters have been eaten by this. So that's going to be the subtree length, but plus the length of all the things in the subtree. So we're going to need to use flatten subtree dot length, so we can skip ahead that many. and then we're going to tree push subtree. Yeah, so we're going to tree push subtree, and then what we want to do is we want to advance the index by this many. So I guess what we can do is we could do like an old school loop. So we could be like index equals 0, and while chars c equals chars at index, and then what we'll do is we will down here we'll go index plus equals to 1, and then what we'll want to do here is we'll want to index plus equals to that minus 1, because we're about to plus 1 anyway. And then instead of, so return tree is going to return this subtree from Tokenize. I mean, we could always return the tree and the length as well, and that might make it easier. But whatever, we can just flatten that. We can get that out of underscore. So what is it? Flatten. That's what we're taking. Equals wire underscore. Okay. Cool. So let's tokenize. Let's watch it blow up. Log tokenize input. Okay, yeah, bam. Ooh, look at that. It got real recursive. Maximum call stack. Okay. So, and then after we're done, return the tree. How about that? Nope, still doing it. Okay, so we are returning oh yeah, because we're not parse floating this tree. So if parse float c, let's try that. Still broken. And chars shift. Oh, we don't want to do that. Just want to do c. Parse float c. Okay, there we go. Tree push is not a function. Tree push equals. There we go. Tree push. So this is still going forever. All right, what do we got here? So we got index equals 0. I guess we can add that here. Okay, so chars equals input match. Okay, so let's log char. No, this is gonna log forever. Okay, so if let's log float c or int, I guess it's a number, and then symbol. And then down here, this is an open paren, and then this is a close paren. Okay, so cool. We ran for a very long time. So int 1 symbol open int 1. Okay, so this is not. this is not right. So we need to join this. Okay. Cool. Let's try that. Okay, no, still not working. So let's check it out. So cool. So again, int 1 symbol plus, and then open paren, and then int 1. So that's interesting. So why is that the case? So well, C is chars index, and then this should give us a new string. this should give us a new string, this guy here, that is a substring starting at index. And it is not. It's just recursively calling it with what looks like the full string, 1 plus again. So substring equals, let's do this. Let's get substring equals this, and then substring, and then we can log substring. Oops, cool, nice. Okay, so substring equals that. Okay, and then that should be calling, oh, input, Jesus, that's the problem. Okay, there you go, substring, cool, so 1 plus 2 times 3 and then 3. So is that correct? I don't know if that's not correct at all. 2 times 3, and then as soon as we got to 2 times 3, it found its first closed paren, and so it returned the current tree, which is 2 times 3, which is what we're expecting. Then it should have continued to parse the rest of this, and it didn't. It just parsed 3 and got the fuck out. And oh, that's because right after we got the subtree, so we wanted to see what the length of the subtree was, and that should have been, let's find out. Log, and we'll say subtree length 3. Okay, so we want to advance index, so let's log the index, and then we'll log the index again. So we were at index 2, now we're at index 4, and then that would have gone on to index 5, which should have been 0, 1, 2, 3, 4, 5. So that would have, okay. I guess what we're doing is we haven't yet accounted for, so we were on this index 0, 1, 2. So the subtree length is this, and then we want to account for the closed paren as well. So let's get rid of that guy. No, plus 1, maybe we need to account for it as well. Okay, plus 4 times 5 plus 6. Okay, cool. So that's what it is. We need to account for the extra character there. Okay, cool. Log. Cool. So this is our finished parsed tree. Oh, Blake's here. Would it help to print the index each time through? Also, hi Blake. How you doing? Welcome. So I feel like we've got this tokenized tree now, and now what we need to do is we need to evaluate it, and we need to evaluate it left to right. So it'd be left operator right, and then so this will be like a reduce. I guess reduce right is what we want to do. Reduce right. Array prototype reduce right. Okay. Applies a function against an accumulator and each value of the array from right to left. Oh, this is not what we want to do. We actually want to do we want to replace the first 3 expressions with what they evaluate to. So we're gonna need, so val u8 value 8. Okay, this is gonna trip me out. You watch. So it's going to take a bunch of args. So we're going to have first, so we're going to have left, operator, and right, followed by rest. Okay, and that's going to, yeah, so if left, if type of left is, or I guess what is this, number? If number is, I guess what we want to do is we want to say unless number is type of left, we want to say left equals evaluate left. So this is gonna, or I guess this is if array, if array is type of left. So if we have an array, then we want to evaluate the contents of it. And we'll do the same thing for right. Okay. Then let's just, cool. Let's, oops. Okay. Yeah, that's fine. Okay. And then we are going to have op. And then we will, I guess we can just do this with an if. If op is plus, we want to have left plus right. Else if op is multiply. Whoop. Then we want to do left times right. Left times right. So this is going to do is this is going to recursively, it should recursively, see, I already fucked this up. This is going to recursively evaluate parentheses until they become an integer. Mind you, this is only going to do it, oh, this is going to go into evaluate, so right, we get evaluated. So it should recursively evaluate the innermost integers. I guess one way to check this would be to try it. So this is only going to evaluate the first three. And then we're going to be left with rest. So in this case, it's going to evaluate these two, and then we're still going to have rest. So what we can do is we can say until rest dot length or while rest dot length, while there's anything in rest, we're going to want to evaluate that and then pass this in as the new left. Oh, David's here. Consider starting with smaller examples. Yeah, you're probably you're probably not wrong. I might want to go simpler on that. So we're gonna have a left, an operator, and a right, and then the rest will start with an operator. So I don't need to worry about that. So okay, and then this whole thing would produce a new left. So I guess I don't need to do this. Well, left. Okay. So we're gonna have left, right, and then we're gonna have result equals that, else result equals that, and then if rest dot length. We want to evaluate. This is tripping me up already. Oh, Blake says, I was about to ask if all the numbers in the input were single digit. Yeah, it is. So I looked at the input earlier, and it looks like it is. rest. I guess we can do rest like that. And then else, I guess result is what we want to return. So let's just fire this up and see if it works. Log evaluate tokenize input, and this gives us a string, which is interesting. So what is left and right? Let's log left, up, right here. So interesting. So this is left and right. Cool. So this is giving us 1 plus, okay. Yeah. Okay. 1 plus, and then this stuff. Whoops. Cool. And then the next one is giving us like 12, 3. Wait, what is this stuff coming from? So I guess maybe what we should be doing is we should be evaluating it here, or we should be logging it there to see what happens. So that's this. And this giving us like 2 times 3. Let's log plus, and otherwise let's log mult. Oops. So plus. Yeah, I'm confused about what it's doing. It's probably like evaluating. It's probably evaluating something as a string when it should be times. Okay, so it's evaluating one. So right, it's not evaluating right. It seems like maybe evaluate is broken. So yeah, look at that. 2 times 3. It's returning 2 and 3. So maybe I'm confused about log res, what it's coming back with. So this is res. Res did 1 plus 2 and 3. So 2 times 3. So it should have evaluated. Maybe array isn't type of right. Let's log type of right. Object. Okay. There you go. Thanks, JavaScript. Hey, 51. Nice. Is that what we're looking for? Yeah, it is. All of that because the whole arrays are an object. Great. Thanks. Thank you, JavaScript. All right. Cool. So let's assert 51 is evaluate tokenize input. And okay, we still got a log in there. All right, there we go. Before I go any further, I'm gonna change this to evaluate. How about evaluate like that? Okay, no, I broke it. Evaluate. Oh yeah, because there was. I just know I'm gonna screw this up. Evaluate. Okay, there we go. It's like a safe eval. Cool. So then let's see. Let's see if this works on the input that we get from the thing. Evaluate tokenize require input. Cool. Do we have an input file yet? We do not. Let's make one. Copy and new file input.coffee. Come on, there you go. Module exports equals bam. Cool, and run it. Undefined, of course. Oh, right, because that's this is actually just giving us the sum. So what we want to do is we want to or this is giving us one line. Evaluate. So this should be evaluate line, I guess. Oops. Yeah, and then what we want to do is we want to map the input through evaluate line. Evaluate line. Cool. So assert that, and then what we want to do is we want to assert that 51 is evaluate input or tokenize runs on a line. So this would be tokenize a line. So and evaluate is just basically split the lines equals text, and this is going to be text dot split on a new line, and we're going to map that with evaluate tokenize input line, tokenize line, and then we're going to reduce that with through sum array, which we've sum array. We're just going to grab this reduce, and we're going to want to parse the input. Parse float. No, this is always going to give us a thing. That's fine. Okay, cool. So evaluate input. So let's see if that works. Undefined, because it's evaluate line. Evaluate input. Nope, still not. Text split is not a function. Qu'est-ce que c'est? Oh, like that? No. Text split is not a function. Evaluate input. Could have sworn text split was a function last I checked. That's super weird. What is text here? Log text. Okay, so that gives us log text. Text split is not a function. Oh, tokenize. We want to evaluate that. There we go. And it's still giving us not a number. Amber alert. Oh shit. Okay. Okay. So it is getting these lines. So is it evaluating all these lines, I wonder? Let's, before we reduce it, let's see what just that gives us. Assertion error. So let's get rid of that. So it's giving us undefines for some of these. That's interesting. So let's take a look at the first one and see what it's this guy here. This is giving us an undefined. So let's log, there, let's turn this off. Evaluate line. Let's work our way up. So undefined, interesting. Interesting. Okay, so evaluate line is giving us undefined, but why is it giving us undefined? So this is because it does it. Is it because it ends with a +8? No, it's not. Is it because it's got two of these in a row? Let's find out. 5. No. Are there any characters in here we're not expecting? So 5, 8 plus. No, looks good to me. Let's get rid of that, and then we'll start logging. So evaluate line. So log left op right. Okay. Okay. Left op right. Left op right. So, okay. So this times 6. Okay. Oh, 6 times. Interesting. So it seems like the op, right. So it seems like we're getting an undefined somewhere around here. So we go plus 3. Okay, and then we get that times 6, and then we hit a paren, a closed paren. And then, okay, so it seems like our logic around is Tokenize giving you the right thing? Yeah, so I think Tokenize is giving me the right thing. Let's check it out. And I think what's actually happening is it's just evaluating wrong. So Tokenize, let's see what Tokenize gives us. It's a good thing to check. Cool. So 5 times 8 plus 3 times open array. Aha, you're right. Look at that. There's a 3 here where there shouldn't be. So plus 3 times 6. So 3 times 5 plus 7 times 2 times 3. Okay, so yeah, where's this 3 coming from? Tokenize. So maybe it's not flattening. Yeah, it seems to be reverting to here times 6, and then it's skipping that. So maybe this whole idea of just moving forward the subtree's length plus 1 isn't right. That seems to be the problem. That's a really good tip, Blake. Thank you. Okay, so what could we do? We could have Tokenize return the tree and any unused characters, and then we could just pull the characters off as we evaluate them, since it's always one character. I think maybe that's a better way to go. Let's try that. So we'll say well, C equals chars dot shift. Okay. And then we can pass in chars join, and then so we'll say subtree. We'll have to do it here. Subtree and tail equals tokenize, and then trees push subtree. And so tokenize now is going to give us back the tree and whatever's left in chars. So in this case, it's going to be nothing. And in this case, it's going to be chars, whatever's left in chars. Except, no, chars is an array. So it's going to be chars join. Okay, so else if C is that, then we want chars. So we're going to tokenize chars join, and then tree push subtree. Is this going to work? Oh, what's this? Index plus 1. We don't need that. We don't need index anymore. Right, and then, so I don't know if that worked. Let's find out. So where are we calling tokenize? Oops, find tokenize. Token, right, tokenize is here. Takes a string in a tree, and then tokenize is down here. So we're gonna have tree rest equals, and we're gonna want to log tree, and let's log rest. Okay, so this is the rest of the tree. That doesn't make any sense. So let's see if this is 5 times 8 plus 3 times 5 plus 9 times 9. See, there we go, 5. We got this weird 5 in there for some reason. Plus 9 times 9. Oh, this is the rest. Or is it, what is this? This is not what we want. Okay, so let's take a look here. So we're tree, push subtree. Okay. And then what we want to do is we want to say, we want to overwrite chars. Can you shift off the beginning of an array? I guess you could. You could just, like, rather than splitting it into an array. And then we would have no regular expressions. So let's do that. Let's say, let's test that we can do it first. Let's just fire up a REPL and say, okay, so we got 1 plus 2 times 3, the string equals that, and then we're gonna say head rest equals string equals string, and then alert head. Let's try that. 1, and let's rest, alert rest. Plus 2 plus 2 plus 3. So that's weird. So I think this automatically made it an array. Oh, that's just because rest. Maybe we don't want that. Head rest. No. Dot join. Oops, come here. No, what is this? What's it saying? Rest.join is not a function. Okay, but when I alert rest, it's giving me this. Oh, right. Because it's splitting it into an array. Dot join. I mean, we could just actually, it would be easier if we just did string O and then string 1. So rest equals, and then head equals, and I guess this could be string equals that, and then we could alert head and alert string. So this is sort of like a way we could do this. 1, and then plus 2 times 3. Okay. Yeah. So while C and then string equals string O and then string 1. I mean, this is just going to give us a slice. So now we're always dealing with strings. And then this can just tokenize the rest of the string. And then this can just give us the rest of the string. And in theory, this could give us the rest of the string. But let's just leave it as, oh no, we do want to, whoops, we do want to return a string. Okay, so what does this give us? 5 times 8 plus 3 times, yeah, it's still doing this dumb subtree bullshit. Oh, I guess that's because it's giving us the tree and the rest. 5. No, that's not correct. Yeah, I don't know if you guys can hear me right now. It's like the YouTube interface is showing that it's down. My internet seems to be up. And it says I'm not live. I don't know. YouTube issue. Continue as normal. Okay, so well, I reloaded Paint and it's working again. Okay, perfect. I don't know why it's being like this, but if it's working, then it's working. Great, thank you, Blake. Cool. So Tokenize. Tokenize. So this Tokenize thing is kind of annoying. So basically what I'm trying to do is I'm trying to go through the string character by character, and I'm trying to push it onto the tree. And then if I get here's the problem. I want to actually set this equal to string again. Undefined. So I don't want to do that. Never mind. Tail. So subtree tail is tokenized string, and then let's log what the tail is. Log tail. Oh, I did that wrong line. Okay, so this is logging, this is the tail, and then it's just logging that as tail. Okay, so what if I string equals tail? Okay, that appears to be working. And then tree rest equals tokenize and then log tree. So I'm not returning the tree. Okay, tree push subtree. Continue if, okay, and I guess what I want to do is I want to say if C, so while C, so this is just going to run forever. So I can just break unless C. Okay, so, and this gives me the tree plus 3 times 6 plus 8, and that's what it ended with, 3 times 6 plus 8. So let's evaluate the line. I guess what we want to do is when we get to the end of the string in total, we want to just return the tree. And then we only want to return the subtree and the tail. This is a terrible pattern, but it is very convenient. So what does this give us? This is going to give us tree rest equals tokenize. So log evaluate line tokenize. Evaluate line. Why is this? What are we logging? We're logging something up here. Evaluate. No. Log. Where's log? Log tail. Oops. Okay. No. There's another log in here somewhere. Where are we? What are we logging? Log. So we're doing evaluate line log left op right. Okay, so this is giving us this number. So I wonder if this number's correct for this line. I guess we could, I mean, we could always find out by just logging the entire thing. So we can still assert that 51. No, this does not work. So what is evaluate input? And what's evaluate line input? So let's see if this works still. So evaluate line works and evaluate input does not work. Evaluate line. Okay. Right, because it's passing in tokenized line, which so let's tokenize. Let's tokenize that. Log tokenize input. Let's see what we get back. We get this back. Okay. And then assert 51 is evaluate line tokenize input. Evaluate line left op right rest. So that's true. So then what about evaluate? Now evaluate is taking text in, splitting it, it's mapping it, and then it should be reducing it. Right. Okay, so assert 51, yes, okay, cool. And then we're logging that works. So cool. So we assert evaluate line is token to that, the whole input is evaluating to that. If we added, I mean, let's just fake it and say, okay, we got two identical lines, and then this should be 102 because it's added together and it's not. So let's find out what that is. So, oh right, it's this one that we're testing, and that is true. Okay, cool. So let's put this back. Cool. So let's log whatever the input is, and it gives us a number, which is neat. So guess what we can do is we can just try it. We can put it in and see if that's the right answer. That's the right answer. Okay, cool. So this works. Let's get rid of some log. Log. Cool. So this is cursively parse. This is apply operator, and then down at the bottom here, so continue if there's more to do, or this is just return res. I guess what we can do is we can just say res equals that, and then we can finally do that. Yeah, okay, and return res. Cool. Neat. So we could probably we're not using flatten anymore, so we can get rid of that. Nice. We could probably add some comments here. Do we need this? No, we don't need that anymore. I don't think. Continue if C is space. I'm gonna leave it in there. Okay. Cool. So this is part one kind of done. let's see just how bad part 2 is going to be. What time is it? It's 3:30. Okay. Hopefully I can get this done before 4. That's what I'm hoping. Because I do need to take the dog out again. Okay, part 2. Okay. Hopefully, I'm hoping part 2 will be pretty quick. That's never the case though. So let's plain. Okay. And some other examples. Part 2. Okay. All right. Let's take a look at this. You managed to answer the child's questions. Good. And they finished part 1 of their homework. Good. But they get stuck when they reach the next section, advanced math. Okay. Now, addition and multiplication of different precedence levels, but they're not the ones you're familiar with. Instead, addition is evaluated before multiplication. Well, shit. Okay, so for example, steps to evaluate the expression 1 plus 2 times 3 are now as follows. Okay, so if you see addition, then that goes before. So really, I guess what we want to do is we could just parenthesize it. Because like 1 plus 2 and parentheses 1 plus 2 is the same thing. And then we could just continue to use our regular crap. So let's do that. Okay, string dot. So okay, let's first figure out in the little test section here. Let's figure out what I'm talking about. 1 plus 2 times 3. So effectively what I want to do is I've got this. What I want is actually yeah. What I want is 1 plus 2 times 3, because then this will get evaluated first. So we could hijack the string on the way in evaluate line, and so we've got like digit plus digit. We could replace it with parens digit plus digit. I think that would probably work, especially since we're evaluating left to right, because it would replace them in that order, I think. Or maybe it wouldn't. Maybe what we'd have to do is we'd have to recursively maybe we can try it and see how bad it is. So the first thing we're going to do is we're going to string equals string dot replace all, and we're going to say digit plus digit, and we're going to replace that with 1 plus 2. Is it like that? Like that? Is that how replace all works? Let's try this. So input plus log input replace all. Except a plus has a special meaning. And we've already got this input. Okay, so replace all is not a function. Yeah, what is it? Is it just replace, and do we want to do it globally? Yeah. What is this? Dollar sign? No. All right, time to look up JavaScript. Ripped regex replace string prototype replace. Okay, pattern regex capture groups. What we want is capture groups. $ number, where n is a positive integer less than 100, the nth parenthesized substring match. Specifying a function. So is it because it's global that it's not doing that? $. I guess replace. Yeah, is there just an example that I can see, maybe? Yeah, okay, replace, regex, capture groups, okay. Okay, I mean, do I have to put it in those guys? Nope. String replace, regex, which is that. Oh, I don't have any capture groups. And then that is always going to be a plus. Okay, so lol. Okay, and what if we had 3 plus 4? What is that going to give us? And what if I globally do that shit? 3 plus 4. Okay, so this is what I'm going to do. And this is going to be string, so string equals string replace. So let's see if this works, and we will see. We'll see what we get. So 231. So we want to assert that 231 is evaluate tokenize input, and it is not. So okay, input is not defined. So that's good. So 1 plus 2, is that the input? No, it's 1 plus 2 plus 3 plus 4 plus 5. So okay, so let's try that. Whoops, that's not where I wanted that. Yeah, let's copy that back out. We want that. So input. So replace all is not a function. Am I still doing replace all somewhere? Oh, on the next line. Don't want that. So that, but that still becomes 51. So let's test that as well. And I mean, we can just tokenize that. Copy, paste. Okay, so we're going to assert that, and we're going to assert that 51 is still this guy. Okay. No. So we're freaking out in Tokenize. So why are we freaking out in Tokenize? Maximum call stack. Okay, so string replace. Another Amber Alert. Ottawa. So not going to be too helpful on that one. Sorry, guys. So we're doing string replace. If we find digit plus digit, we replace it with parens digit plus digit. I guess what we want to do is we want space digit plus digit, or word boundary. We want to make sure that we haven't already parenthesized it. Otherwise, it's going to continue to parenthesize it indefinitely. We could do like a negative look ahead or a negative look behind to make sure that and then I guess we could say the next character here, because it's always going to have the end, is going to be either in parentheses or space. No, that's not true. No, this is just a bad idea. So we can let's log string and see what we get. Oh damn, that's exactly what it's doing. It's just okay. So 1 plus 2, 1 plus 2, 1 plus 2. So it's it's doing this again and again and again. So just replacing that, I guess what we should do is we should do this, maybe we'll do it before the tokenize step. Assert, Mogrify. Let's just make it a new, let's make it a new method. Mogrify equals string. And we'll change the rules on this. And this is just going to be string replace. So we're going to mogrify that. Whoops. I like the word mogrify. I think it's funny. So let's see what we get for mogrify. Log mogrify. So what does log mogrify give us? It gives us that. And what if we log mogrify this guy? Because this seems to be where it's breaking down. Log mogrify. Excuse me. Woo. Okay. And what does this give? This gives us that. All right, so I guess what we're gonna need is we're gonna need we want to make sure that there is not a parenthesis here. Either that, or we want to have an optional parenthesis and then an optional close parenthesis. 4, 5, 6. Yeah, that's it. Okay, cool. So now we've got an optional close parentheses, and that works. So okay, so now we're just munging the input, and I guess what we can do is we can add a couple more rules. So yeah, cool. Let's just grab these and make sure that they work before we go any further. Whoops. There we go. So there we go. And what we can do is we can becomes. So we can assert that that is evaluate line tokenize mogrify. Like that, and that breaks on one of them. Okay, assertion error false equals true on line 84. So it didn't like that. Okay. I mean, did I write it properly? Let's find out. Looks like I is. Just double check that I pasted everything correctly. Okay, so what is mogrify? That. Log mogrify. So this gives me the same 2 times 3 plus 4 times 5. And let's tokenize it. Tokenize. So 2 times 3 plus 4 times 5. Oh, okay. So this 3 plus whatever should have gone before the multiplication string, or before the multiplication step, and it did not. So really, I guess what we want to do. We don't want to do it as a string, because this is, I mean, we're never gonna get what we want that way. So goodbye mogrify, you were fun, and I'll miss you. But what we actually, I guess, want to do is we want to do this at the evaluate step. And what we want to evaluate, we want to go through evaluate line. so it's, I guess it's the evaluate step that we want to do. What we want to do is we want to go through here looking for pluses, and we want to evaluate them first. Okay, so an evaluate line is recursive. We're doing left, up, right, and rest. But what we really want is we want to do, this is just all going to be arguments. Evaluate line, you know what? No, we do want to evaluate this in that order, but what we want to do, okay, so we've got this line, and we're going to tokenize the line. And I guess what we want to do with tokenize is we want to find the groups where we want to go through and we want to find all the bits where there's a plus, and then there's left hand and a right hand, and we want to make those an array. So maybe we can do that. So my idea here is that if we have like 1 plus 2, you know, plus 3 plus 4, whatever, right? Or this would be like a times or whatever. This is already taken care of. But what we want to do is we want to say, hey, if we find a number and then a plus and then something else, what we want to do is we want to convert that into an array like that. So, and then in this case where we've got number and then we got a plus and we got a thing, but it's already in an array, we want to leave it alone. So I guess we want to make sure, okay, so for, what's that going to look like? That's going to be like for I, or for n, or I guess C index in tree. And we're going to do this in evaluate line, I guess. I guess what we should do is we should look at the arguments of evaluate line, because that's where, so we tokenize them. So, okay, so this is going to be tokens equals that. And then what we're going to want to do is we're going to want to mogrify tokens. Okay, and that's where we're going to have this kind of thing. So tokens equals mogrify tokens, and then mogrify tokens is going to do that thing that we wanted to do. So mogrify, and this is going to be recursive tokens. Okay, so how does that, whoops, how does that, don't do that, paste, no, didn't have it in my paste buffer. Okay, so how is this gonna work? This is gonna, okay, we're gonna have 1 plus 2 plus, or 1 times 2 plus 1 plus 3. Okay, so bins that we have, and these are going to be strings. What we want to do is we want to look for this pattern, so something plus something. We want to ensure that it's wrapped in an array. So and then in this case we've got 2 plus something, and we want to make sure that those are contained. So we can always we can always skip if the array length is 3. Okay, so for t in tokens, so we can return, first of all, we can return tokens if tokens dot length is 3. So if we have 3 tokens, we can always just return it as is, because that means that it's already grouped in a paren. So for t and t, or index in tokens, if t minus, or t, or index, was it tokens? Index -1 is, I guess, when t is plus. We only have to do it for the pluses. So we could say if, I guess what we could do is we could always just say, we could always just make it an array. We could say tokens equals, and then we could have tokens up to, or tokens from 0 until index, but not including index. And then we could have token, and then we would have an array of up to and including index -1, I guess. And then we'd have tokens index -1, the token, and then, oops, tokens index +1. And I guess what we should do is we should say, and tokens, we want to make sure that there's a next characters. Oh, I guess there is always going to be a next character if we have a plus. Okay, so, and then we could have tokens index +1. And you know what? I should paren these. Yeah, x +1 ... Okay, so we're gonna explode that, and we're gonna have this array. Okay, cool. So now, so that's gonna give us the outer layer. And if one of those things, that's going to give us like 1 + 3, that's going to get out because it's 3 already. And then what if it gives us this should be a comma. What if it gives us, and this should be a comment, okay, what if one of the sides, so we're gonna have to tokenize this recursively. So okay, so let's say left equals that, and then right equals, no, this is before and after. This is going to be, yeah, it's left and right is tokens -1, and right, so left, and then right is tokens +1. And so we're going to want to mogrify these. So left equals mogrify left if object is type of mogrify. So if it's an array, and type of left, and then right. Oops. Right, and then we have that, and then tokens plus equal +1. Right. Tokens, and then finally down here we return tokens. So let's try this. Mogrify tokens and evaluate line. Tokens. So okay, tokenize line. Okay, so what do I got? Assertion false equals true. So let's just try to test Mogrify on tokenize that. Now let's see what we get. So yeah, that's fine. It was this guy that we needed to check. Oh, that is what we're checking. So that 2 times 3 plus, okay, so okay, we're close. It should have been that, and we got that. So that means that should be index +2. Yeah, okay. Let's see if this blows up on us. Left equals, and then Mogrify left if, okay. Okay, cool. Assert, nope, okay. Assertion false equals true. So that gives us Mogrify tokenize, and then evaluate line tokens. So tokenize line, Mogrify tokens, and then what we want to do is that. So we're going to Mogrify tokenize line. And that should give us 2 times 3 plus 4 times 5. And what does this actually give us? Log. Let's find out. It gives us 26. So does that make sense? Okay, so 4 times 5 is 23. Huh. So it's 23. Why is this giving us 26? So now evaluate line. Let's see what evaluate line is giving us. Log. Okay. So evaluate line, and let's turn off the other logs. All right. So evaluate line. So we've got 2 times 3 plus. Oh, interesting. So we're actually, this isn't giving us. So this is giving us Mogrify tokenize line, and let's log mog. Okay. Oh, because we're doing this in evaluate. So we can't do this in evaluate line. What we'd have to do, we'd have to Mogrify. So evaluate line isn't going to work for these because we are actually doing this in evaluate. So this would have to be here. So, and that would be Mogrify tokenize line 46. Yeah, okay. Cool. So let's go back to these asserts. Are they still running? They are not. Oh, evaluate line, that's why. So evaluate. So, okay. And you know what, let's get rid of those. And we got a bunch of these Mogrifys. Okay, cool. So we can get rid of these logs. Logs. Log. Okay, so that's finished. Good. And these mogrify calls we can get rid of. Evaluate line. Okay, not working. On line 96. So the next one's not working. Well, shit. Let's see. Do the rest of them work? No, not like they get progressively more difficult. Okay. Log that. Now we're gonna log mogrify tokenize line. All right. See where we're falling down. 5 plus. So yeah, it should have done this recursively, and it's not. So that's because we're not. We are calling mogrify. So left, right. Should we try mogrify tokens? No, it's gonna call it recursively. I was thinking maybe it would like find a length of 3 and then get the fuck out, but it's not. Okay, so what do we have here? So the right would be mogrify right if object is type of right. So that would have taken in that and passed it to mogrify. So why log right? Why is two times 3? Where is that coming from? Where is that now? Oh, you know, we got these. Let's turn these off. Okay. So it's not doing that. Right equals tokens. Let's log the right. Return tokens. Oh, if tokens length is 3. So this is the problem. Is the token length is 3, and one of them is an expression. So okay. So return if tokens length. So if if tokens length is 3, we want to, so we want to do left, right. Maybe we can just skip that. No, this is going to give us, okay, plus array. No, I don't. I think this might break these assertions as well. It does not. Okay, does it break this assertion? It does not. Okay, so maybe we don't actually need this, but I'll bet it doesn't. No, it doesn't do that, because 5 times 8 times array plus 3. No, because this would give us 8 times array, and it should be array plus 3. So for t in tokens, so left equals tokens minus 1, right is tokens plus 1. We could actually probably split this with destructuring. Good, like left, t. I mean, whatever. Okay. So the immediate left is the token 1 to the left. One to the right. Okay. So this we can modify left, modify right. And then we're going to overwrite tokens. So maybe this is the way that I'm looping. That is possible. So what is happening here? 8 times, so what's 8? Okay, 8 times 3 plus 9, and that's what got in this array. Plus 3, so 3 plus 9. So we replace that one. And then what we need to do is we need to restart, because we replaced the left. So how do you restart a loop? JavaScript redo loop. You can use the continue to restart a loop. Is there a loop start over? Yeah, what is it in JavaScript? They use these fucking keywords. Continue and break can both be used with a label. Yeah, this is what I'm gonna do. Okay, so for I in tokens.length up to and not including tokens.length. And then what we're going to do is we're going to say, what do we want? And t equals tokens at, I guess this should be index. Tokens index. We can continue if t is plus. So this should give us the same output, and it doesn't because of that. So length. Oh, right. This is actually supposed to be an array. Okay. Now it gives us some weird shit. Up to and not including? Nope. Undefined. We don't. We do. No, we don't. We actually don't want break. 5 plus. Yeah, this is. Let's say index equals 0. And wow. T equals tokens index. And then we can say continue if, well, we want to after we index plus equals to 1. And so here we are. So, and then we're going to have to down here. No, it's still giving us, what are we logging here? This is the output of modify. So let's say JSON dot stringify. Okay, 5 plus 8 times 3 plus 9 plus 3 times 4 times 3. Okay, so that's almost what we want. So, okay, so if t is plus, unless t is plus, unless, okay. We want to continue unless t is plus. Okay. Okay, log right. Okay. Left is going to be tokens index -1, right? Okay, log right. And yeah, let's log right and see what we're getting. We're not doing anything. Let's log t. What? Well, idx is less than tokens.length. Where are we? Log. Hi. This. Go away. Are we just not? Are we not happening? Did we overwrite it somehow? Oh, we're not calling mogrify. Okay. Wow. Okay. Yeah, 3. So we are doing that, but then we should be getting that one as well. Okay, so that's okay. So we're back to where we were. Okay. So we could actually do, well, t equals tokens index. Okay. And this should give us the same output, which is here. Now what we want to do is we also want to wrap that guy, and then Bob's your uncle. Right. So here we are. Get rid of high. Okay, so we're mogrifying left and right. And then what we're doing, so if we're mogrifying the left, we want to mogrify the left, and we want to continue right away thing, and we want to rerun that loop, and that didn't work. So maybe what we want to do is we want to rewind by 1 and then continue. Yeah, okay, so 5, what do we get? 5 plus 8 times 3 plus 9. So no, that didn't work. Didn't work at all. That didn't work at all either. So if object is type of left, this isn't firing in that case. It's mogrifying here. Okay. It's actually when the right is mogrifying. So if it's right, mogrify right, and then we want to, can we just continue? Before we continue, to restart the loop? Nope, that goes forever. Maybe we want to index minus equal. We do want to rewind and try it again. No, that's also going to go on forever. So that's not correct. Okay, let's take a look at what we got again. And so, right. So we're getting this. So we're saying, hey, I found a plus. And so I'm going to wrap this in an array. And then what we want to do is we want to do the same thing here. So this used to be 1, 2, so it was 1, 2, 3, 4. It had an index of 4. And so now what we want to do, or 0, 1, 2, 3. So we did have an index of 3. And now what we want to do is 0, 1, 2, 3. We want to do the index of 3 as well, but we haven't done this step yet. We haven't done this yet. Okay, so we need to restart equals true, and then unless restart, and then restart equals false. So this is gross. And it also didn't work. So this 8 times this, so 0, 1, 2, 3. So this should have been at this index now, and it should have done the same thing for these groups. So if object is type of, right. Oh, you know what? We actually don't want to do that. This is not what we care about at all. We want to. Maybe we don't need to do this manual token advancement, because it does the token advancement here, and every time we do this, we actually change the index. So maybe finding this is enough. Yeah, okay, right, because it'll find it. Beautiful. Okay, yeah, so this index we don't need to do. So if it goes through and it finds a plus, it'll move on. If it doesn't find the plus, then it'll do the substitution, in which case we want to reevaluate. Interesting. Okay. Cool. So I guess what we can do now is, like, let's rerun these assertions and see if they fit. If they work. False equals true on line 103. So it doesn't like this one anymore. So let's log what mogrify does to this. Whoops. Okay, so this gives us 1 plus 2 times 3, which is fine. Plus 4. And I guess, so the problem is that it's doing this. So maybe you want to flatten that, just to make sure. No, we don't want to flatten that. So we want left and right. Left equals left if object is type of left, and I guess what we want to do is if left dot length is the same thing, whoops, with right. No. Right, we'll just do left. Oh. And that can be right. Oh. Why am I making this so difficult for myself? That's the real question. Left, oh, is not a function. Oh, if. Whoop. If. Okay, so now this still gives us super nested arrays, which is not what we want either. What we want to do is, I guess we want to turn token, and we want to say if t length is 1, we want to do t, oh god, wow, return, otherwise return t. Let's try that. No, that's still not doing it, which is super weird because that has a length of 1, or maybe it doesn't. Let's just log the output. Array. Yeah, this has an array. This is a, okay. Why? So why is Tokenize, or why is Mogrify? Tokens map. Oops. So if t is 1, we want to return the first t, else we return just t. Still giving us these like nested, these unnecessarily nested arrays. So why is that? And what are we putting in? 1 plus 2 times 3. Yeah, this is just super wrong anyway. This isn't even making a difference. So Mogrify, what's Tokenize giving us? Log Tokenize. 1 plus 2 times 3 plus 4 times 5 plus. So these should have been wrapped in an array, and they're not. These should have been wrapped in an array, and they're not. Why is that? Because we didn't Mogrify is giving us 1 plus. Okay, because we're not doing the thing as if it's a length of 3 anymore. So maybe what we can do is we can do that. There we go. No, this is still giving us 1 plus array. I mean, maybe. Assert 46. Yeah, okay. We did need that. So 251 is still broken, I guess. 103. So this, yeah, this guy is still broken. What about these guys? Are these broken? Let's find out. Yeah, they're broken too. Oh man, is this guy broken? Yep. This guy broken? Nope. That guy works. Interesting. All right, so what do we got? So 51 is broken. And why is it broken? Maybe the way we're doing this is just stupid. It seemed like a really good idea at the time. So return tokens if token length is 3. So we start the index at 0. We grab the token. We advance I and continue. Yeah, and continue. unless, okay, so it doesn't like that. That's a Rubyism. Okay, so only process additions. Okay. And then what we want to do is we want to get the left and the right. And then we want to mogrify the left and the right. So we want to recursively apply them. Recursively apply. And then what we do is we join them back together again. So tokens. So this is giving us. So this is the bit that we're talking about. The left and right. So I guess maybe we could be smarter about how we put these together. We should really do JSON stringify, mogrify when we're logging these. JSON. Okay, so and let's log that just so it's there. Okay, so 2 times 3 plus 4 times all of that. That should have been evaluated as something to wrap in it. That tokenized it, and then plus 2 times 3. Oh, actually that wrapped it right. 1 plus 2 times 3. And then plus 4 times 5 plus 6. Yeah, okay, so that's actually correct. So this should evaluate first and assert, but assert 51 is that. So we didn't. What is evaluate that? Log undefined. Interesting. Okay, undefined. So this is mogrify. Tokenize line, evaluate line. So what the hell? Why is evaluate line not working? Oh, because right. So left equals evaluate line left if object is type of left. Right. So and we can turn left unless right. That's what it was. Okay, cool. And that, okay, that will just help us to do that. Okay, cool. So assert, let's try this one. Nope. Okay, so that's good. We're working for these. Is that what was wrong with this? No. So these two are still broken. Okay. Yeah, I don't know why this YouTube thing is still like fucked up. It says my stream is not working. I don't want to refresh. Actually, I imagine I should be able to refresh this because this isn't where I'm doing the stream. This is where I'm seeing the stats on the stream. Okay, yeah. So there we go, we're back. Cool. Okay, so these two lines here are still broken. Assert that. So I guess the question is, what are, here, let's grab this. What is going on here? So let's see what this turns into. Oh, this is what we were working on. We were working on that. 5 plus, so Mogrify, tokenize. Yeah, like, what the hell? Why is this not, it's not grabbing these at all? Oh, it's because of the 3, right? Because we took out the 3 and that broke that, and then okay, we don't actually have to. Oh, this will just run forever though. Okay, maybe I'm just I'm worrying about it too much. Cool. Okay, and what about this? Does that work? No. Okay, so next, we're gonna modify tokenize. So we've solved these ones. Now we're working on this one. Okay, and that's the one that's broken. So undefined. So mogrify, tokenize. So mogrify is giving us undefined. That's interesting. Oh, well, it would be less interesting if I just put the string in there. Okay, so let's log that. Okay, so 5 times 9 times 7 times, so this, oh, this 3 plus 9 should have been grouped together, but it was not. And then this 3 plus 8 should have been grouped together. And then this 8 plus 6 should have been, like, all these things that should have been grouped together weren't. So why weren't these passed to Mogrify? I mean, it was passed to Mogrify. And Mogrify should have gone through those and found that right was an object at some point, and it should have mogrified right. And mogrify right should have gone through these and found left and right. So let's log calls to mogrify. Log mogrify. Mogrify. And what are we modifying? Tokens. So JSON dot string out. Stringify. Wow. Tokens. Remove these for now, and we'll remove that assert. So this is the one that we're working on. Okay. So we called mogrify with the whole thing, and that's it. Okay, so left, right. Left is mogrify left. Right is mogrify right if object is type of right. Oh, because we're never adding to the right. So I guess what we want to do is we want to move this process down to here. So we can oh man, only process additions. I guess this is what we want, left to right. We want to, okay, so if t is that, then we want expression. We want the juicy middle to be that. Else expression then we want the juicy middle to be, wow, expression equals double expra equals left right, and then tokens is going to be expra, like that. my package was delivered. Okay. Okay, so that freaked out. JavaScript. Wow, that's a good crash right there. That's pretty impressive. Okay, so we have to use that. Then we're going to add them together like this. Else we're going to not do that, and then this just explodes expression. That's probably not. You know what we want is we do want to do, whoops, we do want to do this. We want to continue. So if t is that or t is that, we want to continue, or unless. Then we want to x plus equals 1, and we want to continue. Okay. Okay, so this is still only calling modify once. I'm gonna run up. So I just had a package delivered, and I want to grab it before it gets stolen. So I'm just gonna nermit. Whoop. All right, welcome back. I got my package. I installed it. So I was thinking about this while I was going upstairs and coming back down to grab my package. That is not an innuendo. And I was thinking about how we're approaching this. Sometimes just a good walk is all you really need. I think maybe I'm making this too complicated. I'm trying to change the input of the tree before I run evaluate line. And maybe what I should be doing is I should just be doing 2 loops in evaluate line. So what we're doing, evaluate line was just, so maybe we don't want to mogrify at all. Let's put a pin in mogrify. Let's just not bother. So evaluate line is what we want to do. So I know that we want to tokenize, so we're not going to mogrify anymore, and that should still assert, but it does not. Assert 51 is evaluate that. So why is that? Did we change evaluate? Let's get evaluate back to where it was. Evaluate. No, looks right. And then what about evaluate line? Are we doing anything different with evaluate line? Because I don't think we want to do anything difficult or different with evaluate line. So let's see what we're doing with evaluate line. So return left and less right. Yeah, that's the only thing that we're doing differently, I think. So what if we kill that? Yeah, it's still angry. Mogrify is not. Okay, so we're calling mogrify somewhere. Okay, where are we calling mogrify? Oh, it's this guy. Okay, right. So that's fine. Okay, so let's just here we'll put this guy way down here. So in case we need to revert, it's still there. So we got evaluate and evaluate line, and so this is really where I think we're running into problems. So first of all, we can pull this out equals arguments, and that should still work, and it doesn't. Array new array set arguments. Is that no? Can I just destructure arguments? Oops. Or let's arg so I can destructure it like that. Oops. Cool. Okay. So we've got the left, we've got the operator, and the right. So I guess what we want to do is we want to go through and evaluate all the pluses first, and they go in order. So, and then we'll go through and we'll evaluate all the non-pluses. So, evaluate line kind of has to change a little bit, or maybe it's not evaluate line, maybe it's evaluate that we want to go through. Evaluate line, left, up, right. So what does a line look like? So it's always an expression, an op, an expression, possibly more ops and expressions. And maybe what we can do is we can leave evaluate line alone, but we want to go through these tuples. So we want to go like I equals 0 and 4i. So this can be bits equals that. And we can say, oh, I don't need to blow that apart. Tokenize line. For I in 0 up until and not including bit stop length. I guess just for bit in bits. For bit in bits. When bit. I guess we're going to need bit and index bit. Is plus. We're going to want to evaluate those bits first. And then we're going to want to go back and we're going to want to evaluate. So we're going to want to apply this operation. Okay, so we got left and right. And we have to evaluate. So what are we doing here with rest? I guess with rest, this is the problem. Is we're trying to do, I think we're trying to do two things at a time in this one function where we're evaluating left plus right And then also, oh, hey, if there's any rest left over, let's evaluate that. And rest. So res rest. Okay. Yeah. Okay. So how am I going to do this? Thinking about it. Also, what time is it? It's almost 5. Okay, I need to take the dog out soon, so I might have to pause this. I really don't want to do that. Okay, so we're gonna have this tokenized line. So let's just let's log that. Oh yeah. Here, let's just go back to the regular evaluate. Where's regular evaluate? Okay. And why are we not logging that? Log. Goodbye, Mogify. Okay, so this is what we got. So we got this tuple and this rest, and then we got this tuple. And then when we get into here, we're looking at this guy. And this guy is becoming this tuple, and then that tuple, and then that tuple. So really, I guess what we want to do is we want to go through and we want to reduce this array by evaluating the pluses first. So if we find a plus, we want to evaluate that. And that could be this, or it could be this. We want to do that plus that. So if we want to find the pluses first, so pluses get a priority. So maybe what we can do is we can do evaluate line, and we can give it a priority. So this is going to give us a single result, is what it's going to give us. And I guess what we want to do is we want to chop the 3 off the array. Okay. If objects tip of left. So we want to do evaluate line once for pluses, and then once for, and then once for everything else. So maybe we can just do that. Okay, so that's going to be if op is plus, also if op is yeah. All right. Yeah, this is going to take longer than I have right now. Okay, what I'm going to have to do is I'm going to have to take the dog out, and I'm going to have to restart the stream. later. So, but that's what I'm going to do, is I'm going to have to step through the tokenized input once evaluating the pluses, and then once evaluating the multiplications. And then I'm going to have to do the same thing. I'm going to have to do the same thing recursively. So this evaluate line is going to be like, it's just going to step through and like a window, you know, so you got, you know, whatever, and it's going to go like, it's going to grab these things and look if that's a plus. And if it's not if it's a plus, then it's going to evaluate and it's going to continue. And if it's not, then it's going to move forward and it's going to be like, oh, what are these? Is that a plus? And then is that a plus? And is that a plus? So that's what I'm going to have to do. But I'm going to have to do it in an hour when I'm back with the dog. Okay, so you can join me then at like probably 6 is when I'll be back. But in the meantime, this has been